Hello, everybody. Today I chat with Chris Stringer, who is one of the top archaeologists and physical anthropologists in the world. AKA, he studies how sapiens became different than chimps and how we became the lone survivor of us and Neanderthals and Homo erectus. And so we do a kind of a big journey there and understand how we became different from chimps. And Chris just does an amazing job of differentiating the key pieces of that story, where we're finding the fossils, what they tell us about things, and then also going forward and thinking about, okay, what story will we know in, because we've learned so much in the last 50 years within anthropology and archaeology. And so he kind of also predicts that into the future and says, with these new kind of protein things that were fossil proteins, essentially, what we're doing with those and how that will kind of provide some much more textured vision of how sapiens emerged. So check it out if you're interested in, anthropology and archaeology and cultural evolution and how sapiens became sapiens. Thanks. Hello, fellow pluralists. I'm Rhys, the co-founder of Root, and welcome to The Rhys Show. This century is a turning point in human history, and I'm here to help you navigate it. I hope you come away with a new understanding of the scientific, technological, and societal trends that are poised to radically reshape our world, and how you can work with those trends to become a live player in building a solar punk future. And to chat with someone who knows about human history from a really deep perspective, I'm excited to chat today with Chris Stringer. Chris is a British physical anthropologist and research leader in human evolution at the Natural History Museum of London, where he's actually worked since 1973, which is amazing. He's also done tons of work on human evolution, including popularizing the recent African origin theory, and has also written lots of books on the subject, including Lone Survivors, which I read recently. Chris, thanks for being on the show and welcome.
It's a pleasure to be with you.
Yeah, excited to dive in. And I think, to give both you context and our listeners context, this is part of a series that, we're doing on the podcast about, trying to understand the time period roughly from 7 million years ago through 10,000 or 12,000 years ago of there were these things that were chimps, and then somehow we kind of popped out the other side. And so trying to understand what happened there. I think Chris does an amazing job of, especially that last kind of 500,000 years, where we started to have Homo erectus, Homo Neanderthalis, and those groups were kind of existing at once. And then we somehow got this modern big behavioral changes with language and rituals and all that. And so, for us, we're trying to understand what happened during that time and, what led humans, and especially our new kind of language and ideas and memes that we could share mind to mind, what kind of allowed us to emerge at that time. So with that kind of context, Chris, could you tell us maybe the easiest way to start with this is maybe for you just to kind of tell us, and feel free to take, a couple minutes about what is the story from roughly either chimp time or 500,000 years ago to kind of, 10,000 years ago, just before the Neolithic revolution? What happened?
Well, okay. Shall I start by going back to that 7 million year period, maybe?
That'd be great, yeah.
Okay, so this is just the really big picture. Explain very, very basically. So we estimate, or geneticists estimate, that we had a common ancestor with our closest living relatives, the chimpanzees, about 7 million years ago. Could have been a bit before that. Some people even favour a bit more recently. So there was a common ancestor, which almost certainly lived in Africa. And then the chimpanzees diverged and went their own way, and we started to evolve as a lineage. But our ancestors, of course, in those first few million years would have looked very ape-like. They obviously did not have the features of recent humans. So if we could have seen those creatures, yes, they would have at first glance looked very similar to some of the great apes of today. Now, the first few million years of that story are very shadowy. There are a few fossils from Africa. There's a thing called Sahelanthropus from Chad. There's a thing called Olorin from from Kenya. And there's a thing called Ardipithecus from Ethiopia. But these are not that well known. They're not very complete, some of them. And there's a lot of dispute about how human they were. So walking upright, for example, is a fundamental feature that defines us as humans. And there is dispute, for example, for Sahelanthropus. Some people think that there's evidence that it did walk upright. So the base of the skull looks like it sat on the spine, suggesting it was walking upright. But there are some leg bones of Sahelanthropus, and one analysis said they were possibly human-like, but another analysis said they were more ape-like. So there's dispute about these early creatures, how definite it was that they were on the human line. And about the first 5 million years of that evolution took place only in Africa. And by the time we get down to about 4 million years ago, we get the emergence of these creatures called Australopithecines, so-called southern apes. And these creatures were certainly on the human line. They certainly walked upright, maybe not exactly as we do, but their skeleton shows signs for walking upright. But in some ways, they were also ape-like. They had small brains, about gorilla or chimpanzee-sized brains. They had long arms. Their upper body still seems to have been adapted to climbing around in the trees. So they were a strange sort of mixture. On the ground, they could walk on two legs, pretty well as we do, but maybe not long distance efficiently, but they could certainly walk on two legs. But when they were up in the trees, they could climb much better than we can, more like a chimpanzee or gorilla. So those creatures were around from about 4 million years down to at least 2 million years ago. So they were an important part of the story. And out of that group in general, something like the first human emerged, the genus Homo. So that process, as far as we know, happened also in Africa. And there are these early species called Homo habilis and Homo rudolfensis, and particularly a thing called Homo erectus. And Homo erectus is pretty certainly, some part of our ancestry. It appeared in Africa probably more than 2 million years ago. And as far as we know, it was the first species to get out of Africa and start to spread, the first human species. So yeah, before that 2 million year period, pretty well, as far as we know, everything was happening in Africa. And then from 2 million years on, we get evolution in Africa, but also it begins to happen in Asia and later on in Europe and so on.
Yeah, great. And then thank you for starting with the bigger picture. And it is interesting how much it's like that 4 to 7 million years ago. It's just kind of like, well, we only have a couple fossils, and so we don't really know what was going on. And then it's also interesting within archaeologic time that you have this kind of, we know that obviously we're walking upright, and we know that chimpanzees walk on all fours. And so it's like, we know that there was a transitionary thing there. And it's just kind of a question of placing it in the right places. And something like Australopithecus, it's like, okay, they did some, it sounds like they're this cool hybrid. And I, in my mind, I think of them as the key difference between them and the chimps is that they started to actually walk upright. But as you're saying, it was a hybrid. And so one thing to double check on that is was it they started to walk upright because of the savanna, because it was hotter, and because there were less trees? Is that roughly the deal?
Yeah, there are many, if you can come up with a really convincing explanation for why they started walking upright and kept doing it, you really make a name for yourself, because it's still one of the most controversial areas. And of course, Darwin way back tried to explain it. He said, well, walking upright frees the hands, and so you can manipulate things, and you can carry things and so on. And of course, once you do it efficiently, it's not bad. As a long distance, for jogging and walking long distance, it's quite efficient. You have a low profile to the sun on the hot African savannas and so on, so you don't overheat as much. So there are all those things that once you're doing it, you can see why it would be a good thing to do. But what would make a creature that was fundamentally more like an ape in its skeleton, what would make it stand up and keep doing it long enough for evolution to work on its skeleton to produce the short, wide pelvis and the changes in the legs and the spine and all of those things which happened. So a lot of the favoured ideas have come and gone. So it looks like tool making probably was important, more than 2 million years ago, but it seems unlikely it was really important 5 or 6 or 7 million years ago. So that may not be a good enough explanation back then. One of the most interesting ideas that's around now is that, sort of paradoxically, walking upright might have started in the trees, and that sounds strange, but orangutans and gibbons, apes that live in Asia, they've got quite long arms, and they often branch walk. So they walk along a branch and they put their long arms up and hold on to the branches above, and they can get out to feed on some of the best bits of fruits and leaves that are at the ends of the branches. So they branch walk on two legs. So in a sense, they do that quite a lot, and that means their skeleton is already kind of adapting to standing upright, even though they're in the trees. So if you imagine a scenario in Africa where that's happening, and some parts of Africa start to dry up, the clumps of trees get further apart. So when they come down out of the trees and want to get to the next clump of trees, they stay walking on two legs, and then they go up in the next clump of trees. So gradually they become more adept at walking upright, and it becomes their habitual pose. Now that's, again, an idea which some people are favouring now. But the short answer is we don't really know. But it was certainly there more than 4 million years ago. And we know that not only from skeletons, where the pelvis is short and wide and the legs seem to show the sort of support we expect for walking upright, but also there are even footprints. So for 3.5 million years ago, we've got footprints in volcanic ash in East Africa, where some creatures were walking on two legs across that landscape. So we know it was happening. Yeah.
That's cool. That's a cool, like, because it feels like so much of the ways that, archaeologists or, physical anthropologists understand the past is through fossils, and now through kind of, genetic, like code and looking backwards in time. But then also, I mean, footprints, that's kind of a cool one. It's like, boom, they're in the volcano, they were hanging out. So do you, and then that the transition to Homo is, okay, we have, in my mind, it's like, in Homo erectus, it's like partially it's tool use, and then brain size, and how those had a reinforcing feedback loop where it's just like we use the tools to get more access to bone marrow and other things. And then we use that we got the bigger brains, and then like vice versa. And before long, we had this massive explosion. Is that the right way to think about Australopithecus versus Homo, or how do you think about that transition?
Yeah, so that transition, again, is one of the controversial ones. What was really driving it? So the earliest Homo erectus, some of them have really still quite small brains. So they're really barely bigger than the Australopithecines and ape-sized brains. So it looks like brain size didn't really kick off for a while. But there are certainly modifications in the skeleton of erectus. So erectus has relatively longer legs. And it looks like, for some people, erectus was a creature which was doing long-distance travel in more open country. So on some people's ideas, erectus moves out into open country, first of all, probably as a scavenger. So being out on the relatively open country, standing upright, looking over those plains, spotting where there's a dead carcass, a carcass of a dead animal, and then getting to that quite fast on two legs, maybe even jogging over to it, and then getting access to that carcass, primary access, before the other scavengers get to it, the hyenas and the vultures and so on. And maybe even competing if they do get to it. You maybe have got some wooden clubs or something, and you drive them away and you get access to those carcasses. And having stone tools, even quite basic stone tools, meant that they could break open some of those thicker leg bones, for example, of elephants and rhinos and hippos. If they could break open those leg bones, they could get access to the bone marrow, which even hyenas would maybe find difficult to get through to get out of those carcasses. So to begin with, it could have been, a lot of vegetables still in the diet, but also supplemented by scavenging, and then gradually meat eating becomes more important. And as you say, that certainly gives increased energy, which will allow the evolution and the running of a bigger brain. And brains are very expensive. They are an expensive tissue. Our brains use about 20% of our body energy, even though they're proportionately much smaller in our bodies. So they're very thirsty energetically, and that meat diet was probably important. And maybe you're a vegetarian, and some people will say, well, I get by fine with my brain on my vegetable diet. And that's true. But because our vegetable foods today have been bred to be quite nutritious, a chimp or a gorilla, they have to eat an awful lot of vegetable foods to fuel their smaller brains. So, meat eating certainly was a more concentrated source of energy, if you like, in the diet.
I love that. And it's like these days the vegetables we're eating, have been hyper optimized, and we have amylase and all these things that like turn, and then they're cooked, and they're versus just like eating like the leaves, eat shoots and leaves, it's like, and so that's cool also to hear. It's kind of like, again, a transitionary hybrid story where it's like Homo erectus, it wasn't like the primary thing that it had was, it's all of a sudden has a big brain. Of course not. It's like, it's this like new hybrid where it's like going from this transitionary trees and walking upright to like, okay, you're probably doing mostly scavenging things, and then you're using that to start the transition into bigger brains and the tool use in order to start that feedback loop. So maybe take us to the next part of the story. Like, what we're at 2 million years ago, roughly, or something. Where do we go from there?
So Homo erectus is in Africa around 2 million years ago, and we find it soon afterwards in the Caucasus, in Georgia, in the country of Georgia. There's a site called Dmanisi, and just over 1.8 million years ago, you've got some erectus partial skeletons there, several individuals. And so they are like the ones in Africa, largely. Their brains are quite small. They're using very simple stone tools. But they're out of Africa. So they're in Southwest Asia, Western Asia. And soon after that, you've got them in China and down in Indonesia, in Java. So erectus spreads widely, again, staying in the warmer parts of the environments at the moment, and doing quite well, as we think, in the tropical areas of Southeast Asia, and also in the more southerly areas of China. But even signs that some of the sites in China, there's archaeology at around 2 million years. So we don't have fossils of those first people in China. And there are also these strange creatures that I haven't talked about yet over on the islands of Southeast Asia. So there's a thing called Homo floresiensis on the island of Flores, nicknamed the Hobbit, a dwarf kind of human-like form, which was still around 60,000 years ago. And on the island of Luzon in the Philippines, there's another creature called Homo luzonensis, much less complete, but again, very small-bodied. And these creatures, they have human features. So for floresiensis, we've got a skeleton of a female, an adult female, but she was only just over a meter tall. She was really small, and she had only a chimpanzee-sized brain, and yet still there, maybe 60,000 years ago. So that's really strange. When the rest of humanity was evolving bigger brains and bigger bodies, over on this remote island in Indonesia, there's this strange dwarf species with rather unhuman body proportions, short legs, rather long arms, very big feet. Rather big flat feet. So a strange
kind of
creature.
hanging, yeah.
And that raises the issue of why is it so odd and where did it come from? And there are two main ideas here. One is the idea that wouldn't be so challenging is that it's actually a form of Homo erectus that got from one of those other islands where we know it was around, such as Java, and it somehow got to Flores, perhaps on boats, but just as likely maybe a tsunami took a raft of vegetation, and it arrived on Flores, and it could have then evolved on Flores for more than 1 million years. And what tends to happen with medium to large-sized mammals on an island with limited resources, evolution drives a smaller body size. So the creatures don't use as much resources, and there are more individuals to be supported. So this could be an example of Homo erectus dwarfing down, not only dwarfing in body size, but oddly, even dwarfing down in its brain size. So that's one idea. But the other idea, which is more challenging and controversial, is that actually it's a form that's more primitive than Homo erectus. So something more like an Australopithecine or a Homo habilis got out of Africa maybe more than 2 million years ago, and then somehow managed to get all the way over to Southeast Asia, and it survives in isolation on Flores, and something similar perhaps happening on Luzon. In the Philippines. So that would be evidence of an earlier dispersal that is very poorly known. But, more conventionally, some people think, well, let's not get carried away. These are dwarf forms of Homo erectus. And frankly, I don't know the answer. And to be honest, I don't think anyone knows the answer yet about where these creatures came from. But we know there was something on Flores more than 1 million years ago because there are stone tools from that time. And there are some small teeth at about 700,000 years. So that really does seem to be a deep lineage on Flores. And there's evidence of a butchered rhinoceros on Luzon that's about 700,000 years old. So something was there butchering animals 700,000 years ago. So these look like really long lineages evolving in isolation.
Yeah. I love that. That's a really cool, it's kind of an interesting, it's like a reminder of, there's like the simple story of chimps to Australopithecus to erectus to, essentially to sapiens. But there's like the more intense story of like, oh, but what was going on? And so it's like, okay, it could be erectus, could be Australopithecus, going and being on the island and seeing what happens to evolution out there. So let's bring us back to the like, if we have Homo erectus 2 million years ago, and they're starting to use stone tools, they're starting to get have bigger brains, and
Yep.
then depending on how you count, 300,000 years ago, 200,000 years ago, Homo
Yeah.
sapiens exists, and then we have behavioral modernity after that. But before even behavioral modernity, what happens in like the 2 million years ago to like 200,000 years ago time period? How does
Yeah.
Homo sapiens begin to emerge?
This is often called the muddle in the middle, and there's a good reason for that. It is a muddle at the moment. It's an area where we used to be more confident about what was happening. There didn't seem to be many species to choose from to make your evolutionary sequences, and now there are more of them, so it's got more complicated. But what we have got is that erectus is obviously evolving through time, and it survives in China and Java for a long period of time. So it's in China until probably 300,000 years ago, and it's on Java in Indonesia probably to 100,000 years ago. So these are really long-lived lineages of erectus, but alongside them, at least in the bigger picture, you've got more derived species, ones that have got bigger brains and show more derived features. And in there, you've got a thing called Homo antecessor, pioneer man, and that's known from Spain at about 850,000 years ago. And that seems to be a bit bigger brained, and its teeth show some evolutionary changes from erectus. And then you've got a thing called Homo heidelbergensis, which is around about 500,000 or 600,000 years ago. And I'm kind of changed my mind about that. So I used to think that was the common ancestor of us and the Neanderthals, and also probably of the Denisovans, who we'll come on to. And so I thought, well, 500,000 years ago, you've got this species, heidelbergensis, and it's in Europe and Asia and Africa, and it goes in three directions. It becomes Neanderthals in Europe and Asia, it becomes Homo sapiens in Africa, and over in the Far East, it becomes something different, which could be the Denisovans that we'll get onto a bit later. Now, I don't think that anymore. First of all, I think heidelbergensis is too widely defined. It's become a sort of ragbag category where a lot of the fossils that don't fit into anywhere else are called heidelbergensis. And I'm partly to blame for that because I started this wider usage about 40 years ago. So I'm partly to blame for that. So I'm backtracking on that. I think it's too widely defined. And somewhere in there, there will be the ancestors of us and the Neanderthals and the Denisovans. But I don't think we know where that ancestor lived and what it looked like. It could have been more like Homo antecessor, but the geneticists estimate the common ancestor of us and Neanderthals and Denisovans lived about 600,000 years ago. But we don't know where it lived, and I would say we're not sure what it even looked like. And so then you've got the appearance of these different lineages. So the Neanderthals, there are fossils in Europe from a site called Atapuerca at about 430,000 years ago, from a place called the Cima del Huesos, the pit of the bones. And this is an incredible place. So deep in a cave system near Burgos in northern Spain, there's a blind chamber, which you can only get by going down a 50-foot sinkhole. So you go down this 50-foot chimney, and I did this, a while back, and it's a pretty terrifying experience. So you go down this sinkhole on a little ladder, spins around as you go down, and in this pit are thousands of human fossils. So there are the jumbled skeletons, probably of 28 individuals, over 6,000 fossils so far. And okay, a lot of those are teeth. And when you combine them all, you've maybe got 28 individuals down there, mostly young adults and adolescents. And they're in this pit deep in the cave. There's one stone tool down there, a nice hand axe, which may or may not be significant. We don't know if one of them fell down there carrying it or it got thrown in afterwards. We don't know. And what's interesting is that originally the idea was that this was some sort of symbolic thing, that they'd been disposed of down there by their brethren, and they put this nice hand axe down there as an offering for them. But slightly less, what can we say, less positive thing is that I think 7 of those individuals have now been identified as having blunt force trauma on the head. So they've had blows to the head around the time of death. So unfortunately, another way of looking at it is that it was a massacre more than 400,000 years ago, and the bodies were all thrown down this pit. But the good news for us is it's a fantastic fossil sample. So you've got every bit of the skeleton represented, and they make a really good source of study. And even more amazing, there's even DNA surviving in these fossils. This is the oldest human DNA ever recovered, probably because it's deep in this cave. The conditions were quite stable and cool. And that DNA shows that these individuals are already on the Neanderthal lineage from their DNA. And that's also what the fossils themselves show. So the teeth of these jaw bones in the Siberia look very Neanderthal-like. So it looks like this is an early part of the Neanderthal evolution about 430,000 years ago. So that's an amazing discovery. So the Neanderthals have branched off already by that time. For our own evolution in Africa, it's tricky to trace us so far back. There are fossils from Morocco from a site called Jebel Ihud, about 300,000 years old. And yes, they show some features of Homo sapiens, but not all the features we've got today. So the face is like our face, but it's bigger, but there's still quite a strong brow ridge, and the brain case is still long and low, which is a feature we find in all these earlier humans. So it's probably time to talk about what makes us different in the skeleton. So compared with these other humans, Homo sapiens, recent Homo sapiens, people like us, we have a relatively lightly built skeleton compared with these other people. So we're less heavily muscled, our bones by and large are less thick, our rib cages are smaller, our pelvis is narrower. If you like, we're more lightly built really through the whole body. And when we get to the head, we've got a number of differences. So we've got this chin on the lower jaw. We've got quite a delicate face, quite flat, with delicate cheekbones. We've got very small or no brow ridge, a high forehead, and behind that high forehead, we've got what's called a globular brain case. So in side view, our brain case is almost spherical, so high and rounded, and that's very different to the Neanderthals or Heidelbergensis or erectus. So those differences are there, and we've even got differences down to our ear bones are even a slightly different shape than they are in Neanderthals. So all these features add up to us having a set of distinctive features. And when we look for those in the fossil record, yes, there are some of them in this Jebel Ihud material at 300,000 in Morocco, but many of the other features are not there. They, in my view, they haven't yet evolved. So evolution is going, slowly towards Homo sapiens, and some of those features come much later. And then probably it's time to talk about the Denisovans. So
get into Denisovans. Yeah, it's like the third big. So I'm hearing the
branch.
Neanderthals are one group.
We've got the Neanderthals are there in Europe more than 400,000 years ago. We've got Homo sapiens at least 300,000 years ago in Africa, and there are some other fossils that are older that might be Homo sapiens, but they're more doubtful, they're less complete. And over in the Far East, we've known for a long time that there are distinct-looking humans in China. So I mentioned Homo erectus in China that was around probably until 300,000 years ago, maybe even later. But alongside them, at about 300,000 years, we've got fossils that look different, that are a bit larger brained, that have, in some ways, a more derived, more evolved morphology. They've got big teeth like erectus, but in some ways they're distinct in their shape of the skull, and these things have been difficult to classify. So some people called them evolved erectus, some Chinese workers call them primitive Homo sapiens. Now, I don't think they show enough features to be called Homo sapiens. In my view, they're different. In the past, I've said maybe they're Homo heidelbergensis, but I think they're actually a distinct group. And I was privileged to work with some Chinese workers on a fantastic fossil from China, from Harbin. So in northeastern China,
I've been there.
Back in 1933, some Chinese workmen were digging foundations of a bridge on the river at Harbin, and they were recruited probably forcibly by the Japanese to do this work. And they found this beautiful fossil skull in the river deposits. They didn't want it to fall into Japanese hands, so one of them wrapped it up, took it home in his rucksack, and put it down a well That was in 1933. And then as he was nearing his death, he told his family to go and look down the well. And incredibly, they found this beautiful fossil. So, and it's wonderfully preserved, and it really shows a distinct kind of human, very large-brained, but a very big brow ridge, a big face, but a face that looks much more like ours than the Neanderthal face. So Neanderthals have got a big nose, and the middle of the face is pulled forwards. But in this fossil from Harbin and some of the other Chinese fossils, the face really looks much more delicate, like our face, but still pretty big. And the shape of the skull, it's not like a Neanderthal, not really like Heidelbergensis either. So this is a distinct group of humans. So we keep that in mind as a distinct species. And my Chinese colleagues actually gave a new species name, Homo Longi, dragon man, to this lovely skull from Harbin. I'm a bit more cautious. I think it's similar to another skull from China that was found more than 50 years ago from a site called Dali. And that actually has a species name that can be used, Homo daliensis. So I think if there is a distinct species in China, we should probably call it Homo daliensis, even though Dragon Man is such a great name.
Yeah.
But Homo daliensis, from my point of view, has priority. Okay, so hold in your head that, okay, we've got this separate lot in China that are not Neanderthals, not Sapiens, they're not erectus, they're not Heidelbergensis. And then we've also got the discovery from DNA of a distinct group of humans in Siberia. Mm-hmm. So there's a cave in Siberia and Russia called Denisova Cave. And Russian archaeologists have been digging this cave for more than 50 years. And they found lots of animal remains, lots of stone tools, and some fragmentary human fossils. So if we fast forward to 2010, incredibly, geneticists were able to recover DNA from these fragments. And a tiny piece of finger bone produced a whole genome of a new kind of human. It wasn't Homo sapiens, it wasn't Neanderthal, a different kind of human, which we now call Denisovans. And the physical remains of these Denisovans is still very limited from the cave. You've got a few teeth, you've got this finger bone, there's a little bit of skull still to be published, and there are lots of smaller fragments that are Denisovan, and there's even Denisovan DNA in the cave sediment that shows they were living there for probably 200,000 years. These Denisovans. And incredibly, not just them, but the Neanderthals were living there at times too, because there are also fragmentary fossils that have got Neanderthal DNA. And they were in the cave as well at times. And at times they must have been there at the same time as Neanderthals, because there's even a hybrid of a Denisovan and a Neanderthal. So there's a little bone fragment which has mitochondrial DNA of a Neanderthal. So it's got a Neanderthal mother, but its genome shows it's about 50% Denisovan and about 50% Neanderthal. So this is a girl who actually had a Neanderthal mother and a Denisovan father, found in this cave maybe from 100,000 years ago. So it's just astonishing, really. Yeah. So both those populations were there at times, but the Denisovans, so we've only got these fragments of them, they've got big teeth and distinct DNA. They seem to branch off the Neanderthal line more than 400,000 years ago. So they're kind of, on the DNA, related more closely to the Neanderthals, slightly closer to Neanderthals than to us. Cool. And then there's a jawbone from the Tibetan plateau of China, from the Zhaohe area. And this jawbone was found a few years ago, very robust. It's got big molar teeth, so like the Denisovans in that sense. No sign of a chin on it. So it looks really quite primitive, the jawbone. And unfortunately, no DNA in it, but a tiny bit of protein was recovered, proteomic material. Mm-hmm. And that protein material linked it with the Denisovans rather than the Neanderthals. So this could be a Denisovan jawbone from the Tibetan plateau of China.
Yeah, and let me yes. I mean, that's a great overview of okay, so we had erectus, and then we had the muddle in the middle from let's call it 500,000 years ago to 2 million years ago, where it's what was going on there? We don't really know. You had this thing of, and I've never actually heard it spoken. Homo Heidelbergensis. How do you say it?
Yeah. So
say it one more time.
Named Heidelbergensis. So
Heidelbergensis. But before going deep into it,
yeah.
Oh, got it.
So
Heidelbergensis.
That name was given back in 1908, and I kind of co-opted it for this wider group of humans. Yeah.
Heidelbergensis, yeah, and then Heidelbergensis, and then we have the Neanderthals going kind of north into Europe, and then the Sapiens staying in Africa, and then the kind of Denisovans going, maybe being Neanderthals, tough to tell, but going kind of east into Asia, Siberia,
Yeah.
that kind of thing.
And they're
And then,
evolving there probably for hundreds of thousands of years. So you've got
yeah,
Neanderthals going over in the western end of Europe and Asia, and these Denisovans are all evolving over in the eastern end.
yeah,
And of course, I've mentioned these Chinese fossils, like the Dragon Man. So a lot of people think, well, it's all very simple. Dragon Man is a Denisovan. And so
mm-hmm,
we don't have its DNA, but that's probably what the Denisovans look like. And that
yeah,
could be correct.
mm-hmm,
So, you've got this coincidence of a deep lineage in East Asia from DNA that's different from Neanderthals and Sapiens. And then you've got this deep lineage based on skulls, like Dragoman and Dali, with no DNA. Well, why aren't they one and the same thing? Let's
yeah,
call them one day. But we shouldn't go so fast, because
yeah,
we really need to get DNA from some of these Chinese fossils
mm-hmm,
to really show their Denisovans.
cool.
Some of them almost certainly are, but we need to really prove it. Yeah.
Yeah, and and then pull me to this time, because a thing that I kind of think of this as like a Cambrian explosion of Homo adjacent things, where it's like, okay, we got these big brains. Those big brains start to allow us to not just exist in this niche in the savannah in Ethiopia and Kenya. It's like, no, you can just like we like spread out into the world, and we're able to do things in an amazing way all throughout the world. Is there and then this like behavioral modernity, and I guess I want to like we have, the way I think about it is that we had these kind of, and I'm not sure how much you're down this rabbit hole, but we have, genetic replication, selfish gene, that created the whole tree of life, the whole biosphere. And then we have like mimetic replication, or like ideas spreading from mind to mind. And that then obviously it created all of cultural evolution. It created the tree of ideas. It created everything we know today, technology and ideas and narratives. And but like it started, at that time, and there were rituals happening, and there was burials happening. What kind of had the behavioral modernity start? Is that when language started? Tell me more about that kind of time.
Yeah. Well, these are very tricky questions, of course, because language doesn't fossilize.
Yeah,
We've got stone tools, of course, and some of those are beautifully made, including by Neanderthals. But on their own, of course, they don't tell us that they were speaking to each other. But I think language evolved out of social complexity. And I think when we look at the life of the Neanderthals, it's complicated. They are living in reasonable sized groups. They're hunting some dangerous animals. They're making really quite complex tools. They're using wood. Often that doesn't preserve, but some of them are skillfully making wooden artifacts as well as stone artifacts. There's increasing evidence that they're using some forms of jewelry, pendants. So there are shells, there are eagle talons, there are various things which look like they've been made to suspend as necklaces or bracelets, even from Neanderthal sites, and a lot of use of pigment. And okay, some of that pigment could be functional for softening skins or keeping insects away, but there's a lot of it in Neanderthal sites, more than probably could be explained functionally. So the idea is that Neanderthals were probably marking their bodies with pigments, just as early Homo sapiens was. There's even suggestions that they even were marking the cave walls. That's more controversial, but there could have been some form of basic cave art being produced by Neanderthals 60,000 years ago in Spain. And there's one really complex structure deep in a cave in France, in Bruniquel Cave. They found this couple of ovals made of stalagmites, broken stalagmites. So someone 175,000 years ago built these dry stone wall structures deep in a cave, far away from the daylight. Now, 175,000 years ago in France, we only know Neanderthals were there. So for some reason, the Neanderthals built these structures deep in a cave where they must have had artificial light. And so this suggests complexity. So I think Neanderthals had language, and the gap between us and them has certainly narrowed. So 20 years ago, I'd have said to you, yeah, modern humans are producing art. We're the ones producing complex tools. Maybe Neanderthals buried their dead, but they did it very simply. We did it in complex ways. We had full language, and they maybe had a very simple communication. Now the gap has really narrowed, and we can see that the Neanderthals share a lot of our complex behavior. But of course, the more like us we make them behaviorally from the evidence, we've still come back to that big question: was if they were doing so well, why aren't they here now? Why is it only us? So it's back to that question of lone survivors. Why are we the only humans left? And of all these different kinds of humans I mentioned, and I haven't even mentioned some others that were around. So there's a thing called Homo naledi in South Africa about 300,000 years ago, another strange species. So all these other forms, and there are at least 20 of them, all of them, human diversity in the past was huge with all these different coexisting lineages, and yet now there's just us. So what happened? And that's really a huge question. And we don't have the full answer, but those other species, certainly Neanderthals, Denisovans, floresiensis, maybe luzonensis, maybe erectus too, disappeared as Homo sapiens was spreading out. So sapiens made some excursions from Africa before 60,000 years ago, but around 60,000 years ago, there was a major excursion of sapiens from Africa starting to enter the territories of these other humans. And within 20,000 years or so, the Neanderthals had physically disappeared. The Denisovans disappeared at some time, we don't know when. Floresiensis disappeared after 60,000 years. Luzonensis after 70,000 years. So it seems to be more than a coincidence that the spread of Homo sapiens is followed by the disappearance of these other species. But how did it happen? Was it an intentional process? Did we kill them off? I think it's more likely that we just were using resources more efficiently, more effectively, collecting the same plant resources, collecting the same animals and hunting the same animals, wanting to live in the best cave sites and so on. And there was an economic competition, and we, for whatever reason, won out in that competition. But it wasn't a complete extinction, of course, of these other species, because we know from our DNA that, you and I have got maybe 2% Neanderthal in us, surviving from ancient interbreeding, and people over in the Far East and Southeast Asia, some of them have maybe 4% of Denisovan DNA as well. So these species partly were absorbed into the Homo sapiens gene pool, and some of that is still with us today. So they didn't completely die out.
Yeah, it's a kind of a cool, and some of those things have COVID indicators. Some of them help, Tibetans in the Tibetan plateau have, I guess, more Neanderthal DNA. And so they have better oxygen, cold things. And so tell me about that, that behavioral modernity 60,000 years ago, and then we start, what is, if I think about, we're getting close to the time here, but what do we, about 10 or so minutes left, but what do you think about, today we have our versions of cultural evolution, which are these, whether it might be the technology that spreads and, now we have the internet, blah, blah, or maybe it's cultural evolution in terms of a dance that becomes popular or whatever. What did cultural evolution look like back then? And how did ideas and things spread?
Yeah. So of course, they spread by mainly human contact, by networking. So one of the things that could have been different is that Homo sapiens were in slightly larger groups and we networked more widely across the landscape. The Neanderthals did it too, but there's some evidence that near the end of their time, the Neanderthals were relatively low in numbers and low in diversity, genetic diversity. So they may have been, to some extent, a threatened species even before we lived alongside them and maybe outcompeted them. Denisovans are more of a problem because they were probably down in Southeast Asia as well as up in Tibet and Siberia. So they covered a wide range, and we really don't know what led to their disappearance, but we know there was interbreeding with them. So, yeah, I think if you're looking for the smoking gun of behavior, it's difficult. It used to be cave art, but we know Neanderthals were doing some of that. They had symbolic expression, but there's still, as far as I know, there's no sound evidence that Neanderthals produced figurative art. They didn't depict human figures or animals, whereas we know that modern humans 40,000 years ago were doing that in Europe, and they were doing it, we now know, in Sumatra and Borneo. So Homo sapiens, right over the other side of the inhabited world, were painting cave walls with animals. So there could be something different there in that artistic expression. And also in the kinds of tools. So Homo sapiens, at least by 40 or 45,000 years ago, they're producing many more specialized tools and some quite tiny tools. So there's a site in France called Grotte Mondrian, and I was involved in publishing that recently, where there are thousands of tiny little points which look like arrowheads, but this is a site that's more than 50,000 years old. with the really early appearance of Homo sapiens. So, whether it really is arrowheads, but there's certainly some very distinctive technology there, which we don't find by and large with the Neanderthals. So there could have been particular technologies that we did a bit better. Maybe we exploited the environment more intensively. Having weaving to make nets, that means you can catch larger numbers of fish, you can catch small game using nets. And maybe if we had that and Neanderthal didn't, that also could have been a factor in our success.
I love that. I love that as a part that of your book that I remember and was like, oh, this is smart. It's like, yeah, the idea that you can start to look at population sizes, and then in East Africa, aroundish the time of behavioral modernity, it's like, okay, the population size gets to be enough such that the amount of culture, the amount of like knowledge that you're gaining each generation or passing down is greater than the amount that you lose.
Yeah.
And so it's just like,
and also, the survival of older people. Having
yeah,
grandparents and even great-grandparents, they are a store of knowledge as well.
yeah,
Maybe they
exactly.
remember the last time there was a famine, the last time that the herds of animals disappeared, and how did they survive that? So
Yeah,
they're a store of knowledge as well. And the survival of really old people is something that I think it comes particularly with Homo sapiens. It's not
yeah.
there so much with these other species.
I,
And also just the degree of networking, as I say. So that's your insurance. Again, if you've got neighbors that are friendly and you're related to them, you can exchange knowledge and help each other out in bad
yeah.
times.
I love that too, as like a thinking of, because we think of like a thumb drive as a way to like store knowledge, or like, Google Drive or something, but it's like actually old people, it's the wisdom, but it's like old school. That's all we had. Do you
And
think?
they're the ones who'll remember the deep kinship systems, because they'll know if you're meeting another group, you're another group. Are they friends or neighbours? Well, if those old people can remember, oh yeah, my my sister, married one of them 50 years ago,
Yeah.
whatever.
That's great. Um, and how do you think about like co-inheritance and gene culture evolution, and thinking about at this beginning time, obviously genes were the primary drivers of things for a long time, and they were primary replicators, and they were trying to access energy, blah blah. But then we have these, the meme starts like, oh, if you have this idea that can spread from mind to mind, like to do basket weaving or a certain stone tool thing, like that's the thing that really starts to then drive a lot of like our own body changes, but also like what is propagating successfully
Yeah,
in the world.
and that allows us to survive in environments where our bodies are simply not adapted to naturally. So going into the desert, we have a lousy physique for surviving in the desert compared with many other species of mammal. We have a lousy physique to survive in hot, humid forests, but our culture allows us to do that. And that obviously is a key to our success too.
Yeah. And I guess, do you like, how do I say this? Like, is there, or let me ask, yeah. It's interesting. I think there's this big story from, and thank you for walking us through all that. And then getting to this, the quote unquote modern sapiens, and how, and also how it's a complicated story and those kind of things, but also how it's like, okay, we did start to like, our skills at sharing tools and sharing ideas from mind to mind, it became really, really powerful. Do you, maybe as a final, maybe two final questions. The first is, do you, how do you see, what's the way to say this? I guess like, taking this deep historical kind of fossil perspective, um, maybe you can even say like 50 years from now, or even 100 years from now, like what are we going to understand about our history as a species or whatever, and past that, and how will that change how we operate, today or whatever?
Yeah, that's very different. I mean, looking ahead on ideas, I mean, 20 years ago, I couldn't have predicted a number of these new species that have been found, nor just the richness of DNA technology and what it's shown us. And I think there's looking at fossil proteins. I mentioned that with reference to this fossil from the Tibetan Plateau of China. I think using fossil proteins is going to give us a window that takes us beyond ancient DNA, because ancient DNA, it doesn't survive long term. But those proteins could have let us look at Homo erectus and the relationships at Heidelbergensis and Antecessor, even Australopithecines, and those really early things from Africa. We could start, if we can recover fossil proteins from them, we can start to relate them to each other and to us, and really clarify the pattern of human evolution, where you've got the muddle in the middle and then an even bigger mess going further back, I would say.
I love that. It's like, yes, we're going to be detangling the mess. And the final thing here I want to ask is just like, so overrated, underrated. So I'm going to ask you, and you can just respond with like a little, 30-second quip, or rather the thing that I say is overrated or underrated. And so what do you think? Do you think that like fire was overrated or underrated?
It was important. I mean, once you can make it at will, it's very important. But these people got along for a long time without fire. Neanderthals could make fire often, but they didn't bother to. They ate their food raw often, even though they could make fire.
So is that, I'm hearing underrated there? Or sorry, I'm hearing overrated?
It was important. I mean, certainly it's going to kill pathogens and it will soften your food. But maybe it wasn't as essential in the early stages of human evolution as some have argued.
Beautiful. Love it. What about like tools, stone tools?
Yeah, very important. And not just stone tools. As I say, things made of wood, for example, were very important too. And we've lost most of that evidence. Things made of skin, all of that. But yeah, stone tools were critical. Even that scavenging phase would have been, impossible without having stone tools, because we just haven't got the teeth to crack open thick bones. But the stone tools let us do it.
Amazing. And then maybe the final one is like, I guess, do you think that I'll just ask like it was being in groups, overrated or underrated?
Oh yeah, being in groups and large social groups. Yes, I think that was critical. So for survival, large groups were one of the keys to our success in our spread around the world. Definitely. Yeah.
Love it. Beautiful. I love how you also, for each of the overrated, underrateds, you kind of dodged. You didn't actually say it, but you're like, this one is important. This one,
Yes,
well,
yeah.
Yeah, exactly. Well, thank you, Chris. I think you do a great job of, for our listeners. Yeah, feel free to check out Chris. Chris is is actually one of the best. Not that many of the like physical anthropologists and kind of great kind of archaeologists are on. I mean, there are lots of good ones on Twitter, but Chris is on there and like actively does Twitter, so that's great. He's Chris Stringer. That's Chris CHRIS and then Stringer STRINGER 65. So definitely check him out on Twitter. Check out any of his books. I mean, he has this Lone Survivors is kind of looks at all these different fossil records and like tries to understand, kind of says, hey, we found this and that's what it means here. And
can I put a plug in for Our Human Story, which is
I was about to say,
you got that one. Yeah.
Yeah, and Our Human Story, I think, is an amazing story about it's like these 25, and I actually haven't read it, but it's on my to-read list of like these 25, it's like all these different new species that we're learning about and what they tell us about our kind of history as a species. Is that right?
Yes, that's right. Yeah, and we've got a new edition coming out very soon.
Cool. Yeah, so definitely check that out, Our Human Story. Chris, would you like to say anything else to our listeners today?
Well, no, just to thank you all for listening and to say, maybe I'll invite me back in a year and see how much things have changed, and I'm sure they will have changed.
Yeah, it's awesome. I think that's a great thing, Chris, that you're doing is, you do a really good job of both. At the beginning, you start to say, hey, out of Africa theory. And then now you're like, wait, let's call it the recent African origin theory because it's more complicated. And hey, there's this Heidelbergensis thing, but you're like, that was a good placeholder at the time, but now it's more complicated. So I think you do a good job of like adjusting to the times and following where the evidence is. So thank you so much, Chris. And thank you everybody for listening. Goodbye, everybody. Thanks so much for listening today. If you liked the show, please give us a 5-star podcast review or subscribe on YouTube. And if you'd like to chat about this episode with a community of amazing, smart, ambitious, divergent people, come on by and join our Discord. You can find it at root.co. That's ROOTE.co. And then finally, if you'd like to contribute to these ideas being shared more widely in society, you can support the podcast production team at patreon.com/Rhys Lindmark. That's patreon.com/RHYSLINDMARK. Thanks, and see you here for the next episode. Bye.